Hypothesis testing is very important. What is hypothesis testing? And why should we learn hypothesis testing? So usually we have so many assumptions that clinicians, doctors, and also statisticians make. Now these assumptions must be tested or proven. And to do that, we undertake what is called a statistical method that will determine our premises, whether they are true or false. And so we undertake what is called hypothesis testing. So by definition, how do we define hypothesis testing? So hypothesis testing basically is a statistical method that is used to test whether an assumption about a population parameter is supported by the sample data. So hypothesis testing involves formulating the null hypothesis, which will represent an understanding of a parameter, and also includes what is called an alternative hypothesis, which will give a new alternative of the understanding. So after you're done with the hypothesis testing, you need to state the level of significance. And then you need to test the statistic using what we call the calculated Z. We also will determine what is called a p-value, which is based on the probability of observing a test statistic under the null hypothesis. So hypothesis testing is used in various fields like medicine, psychology, economics, engineering, to determine the effective
Sir, I'm all right. How are you? I'm okay. How are you?
assumptions that people make. So in hypothesis testing, we evaluate the significance of the findings, and we also make decisions based on the data. So hypothesis testing could have the following steps. Number one, you state the hypothesis. And the hypothesis comes in two ways. We have what we call a null hypothesis and the alternative hypothesis. So null hypothesis is always denoted by H0. This is called the null hypothesis. And we also have the alternative hypothesis, which is denoted by H1. Alternative hypothesis is H1. All right. So now let me delve into explaining what those two mean. What's the difference between the null hypothesis and the alternative hypothesis? So we've heard of these terms, null hypothesis and alternative hypothesis. What is the difference, and what do they imply? How do they help us in research? So when we're dealing with a null hypothesis, we're looking at the original thought. That we want to test. Alternative is just an alternative thought that we may have. So I'll give you examples that will help you simplify this thought that I want you to understand. But just to define them briefly, I'll write them as follows. When we're discussing the null hypothesis and the alternative, they're competing statements about a population. So null hypothesis is simply a statement that there is no significant difference in the parameters of interest. Whereas when you're discussing the alternative hypothesis, there's always a significant difference in the parameters that are of interest. So step 2, we're going to state the what? The level of significance. So we have 5 or four levels of significance. Remember them. Number one, we have what? 1%. What is Z for the 1% significance level? 2.58.
2.58.
We have a 2% level of significance. What is the Z value for 2%? 2.33. We have a 5% level of significance. What is the Z for 5%?
1.96.
We have a 10% level of significance. What is our Z?
1.65.
1.65 or 645. So that's the second step. And the third step is to make a decision rule. So the decision rule is based on the levels of significance. For instance, if we are at 1%, we're going to reject HO if it is in a shaded region. So on the left side, the two-tailed test we're going to look at, we have negative 2.58. So the answer will be in the shaded region, we reject for the rejection region. Then on the other side here, we have positive 2.58. So this is called the rejection region. This is called the accept region. Suppose we're dealing with 5%. What are the critical values? 5% here we have what?
1.96.
And on the other side we have what?
Positive 1.9.
Positive 1.96, correct. So this middle area is called what? Accept region.
Accepted region.
And the shaded region is called what?
Rejected region.
Yes. Also, we could have level of significance what? 10%. So we reject HO if our critical values are achieved. So here we're going to have 1.65 and here 1.65 as well. Now, you need to understand that to reject a hypothesis sometimes or often cases is a good thing because it means there's a statistical difference. So what does it mean when we are accepting the rejection, we are accepting the hypothesis? So here in the accept region, it means there's what? No statistical difference. And when we are rejecting, it means there's what? A statistical difference. So that is on the third step. And the fourth step, we calculate Z. So we calculate what? The test statistic. Calculate the test statistic. So depending on so we have Z calculated is simply equal to X bar minus mu over standard deviation square root of N. If you're dealing with proportion, Z calculated is P hat minus a proportion over PQ square root of what? Everything over square root. So we only use Z when we're dealing with samples greater than N. So if samples are less than N, we're going to use the T calculated, which is the same formula for a single sample, S over square root of what? N. Except that this one is used when we're dealing with N less than 30. Then the fifth step is simply to make conclusion. So the conclusion will be either to what? Reject or to accept the hypothesis. So when you reject the hypothesis, it means what? There's a statistical difference. When we fail to reject, so in at master's level, we don't usually use the word accept because it may not be the exact premise that you have. So we say fail to do what? Fail to reject. It's the same as accept. Fail to reject HO, which means what? There is no difference at all. All right. Now, let me take it to your farming season. So there will usually be two means that you'll be given. One is statistical and one is hypothetical. Statistical is calculated. So Zamseed is advertising their new seed brand called ZC111. So it is assumed that the mean tonnage that you're going to get, if you're not going to use this seed, you're going to get what? 15 hectares with normal seed. You're going to get 15 tons. But if you're going to get this tonnage that you're going to give us, it is X bar because you calculated it. Maybe you're going to get 20 tons. Okay, from how many plots? Maybe you're using 36 plots, and also your standard deviation maybe 12 tons, and the level of significance is 5%. So you're going to be asked to state whether it is significant enough to use ordinary maize or to use this new brand. So I repeat, it is believed that when you use on ordinary seed, you yield 15 tons. So 15 tons is a historical mean. It is mu, it is not calculated, it is an assumption. Then X bar is actually calculated. So it says after you sampled this new seed in 36 plots, it was able to yield 20 tons with a standard deviation of 12. Can we conclude that this new seed is effective? We cannot say yes or no until we follow the hypothesis testing procedure. So we now, step one, state the hypothesis. All right, our mu, meaning the historical mean is what? 15 tons. And here we say it is not equal to what? 15 tons. Obviously, it's 20 tons. But want to see the difference. Second step, state the level of significance, which is 5%. Step 3, state the decision rule. Based on the 5%, we know that 5%, the critical value is negative 1.96 here and positive 1.96 there. All right. So you make a statement here to say reject what? HO if our Z calculated is greater than 1.96 or our Z calculated is less than negative 1.96. And our fourth step is to calculate the Z. So how do we calculate the Z? Z is equal to what? X bar minus mu over standard deviation root of n. So X bar here is what? 20. Mu is what? 15. The standard deviation is what? 36. Standard deviation is 12, sorry. Over square root of what? 36. So 6 into 12 is 2. Then 20 minus what? 15 is 5. So 5 divided by 2 is 2.5. So we're going to identify where the 2.5 is somewhere here in the shaded region. So what does this mean? We reject HO. Why? Because Z is greater than 1.96. So what? Is there a statistical difference or no statistical difference? There is a statistical difference. So it means the new brand is effective. So you comment your decision based on two critical values. Number one, we reject HO. Why? Because our Z calculated is greater than 1.96. Conclusion or decision, new seed is what? Effective. Why is it effective? Because there's a statistical difference. If we accepted, it would have been in the accept region. All right. So we're going to go to another question. We're going to go to another question so that we have a broader understanding of what is actually happening. So some of these things you get to understand them more as you solve more questions. All right. Any questions before I proceed to the next question? Okay. So we
Sorry, Collins. I'm a bit behind on how the 5% gave the two parameters of 1.96. That part.
I think you missed the previous classes. That is
Yeah, I did.
where the question is coming from. All right. We learned of a song at lunch in that 18 hours today, where those parameters are coming from. So I've sent the video for you to understand so that I don't explain this again.
Okay.
So we have 99% confidence level, 98% confidence level, 95% confidence level, and 90. The difference from 100 is called the significance level. This is 1%, and here we have 2%, and here we have 5%, and here we have 10%. Then when you divide this by 100, we call this our alpha, which is 0.01, 0.02, 0.05, and 0.10. Then we learned how to get this from the tables, but if you didn't learn, you can still memorize. And 9% is equal to 2.58, 98 is 2.33, and 95 is 1.96, and 90 is 1.645. So in our previous example, we're using 95%, so the Z that we're using is 1.96. Okay. So visit the previous classes so that we I'll repeat these lessons on Sunday, but it will help you to listen to the video. So this is where we're getting the figures from. All right.
Thank you.
So we can look at another question. On hypothesis testing. So the question says, it is assumed that that public workers get 5,000. Uh, 5,000. Okay. A sample of 49 teachers or 49 workers were found to earn 4,700 with 300 kwacha, with 200 kwacha standard deviation. Test this assumption. Test this assumption at alpha 0.02. So there's a claim on the rumor that civil servants get 5,000. So let's identify which one is our X bar and which one is our mu. So you're able to tell which one is your mu because it has no sample size. So this 5,000 is our mu because it's just a rumor or an assumption. And this 4,700 is our X bar because it was actually calculated. There's a sample size. A sample size of how many? 49. So N is 49. And whenever N is greater than 30, we use Z. So Z is what we're going to read using this alpha level. So this alpha level is 0.02, meaning Z is what? 2.33. It is the same as 90 what? 98%. So if we go to our previous calendar here, it simply tells us that 98% is 0.02, which is 2.33. So this song has to be memorized. All right. And our standard deviation is what? 200. So we follow a 5-step procedure. Now hypothesis contains the what? The mu. It is assumed that they get 5,000. So our null hypothesis is 5,000. Alternative is just maybe they don't get 5,000. After all, this is just a claim. Step 2, the level of significance at 0.05 is what? 2%. So meaning our decision rule will be reject HO if it's more than what? 2.33. So these are critical values. Negative 2.33 here and positive 2.33 there. Okay. Then step 4, we calculate Z. Z calculated is what? X bar minus mu, standard deviation over what? Square root of N. So our X bar was what? 47. And our mu is already in the hypothesis, which is what? 5,000. Now standard deviation is what? 200 over 49 teachers or public workers. So in this case, if we got our answers 1.67, can somebody give me a conclusion? What answer? What do we conclude? 1.67, what would you say? It is inside here. So we fail to reject the hypothesis. We don't have sufficient data to dispute the fact. The person who's saying that they get 5,000 is close to the truth because 5,000 and 4,700 are within the same range. So we accept, because this is accept region, that 5,000, the civil servants gets 5,000. If our answer that we got here was negative 2.67, where's 2.67? It will be somewhere here in the rejection region. So what we say, we reject HO and conclude that this person who says that they get 4,000 or they get 5,000 is a liar because the difference of 300 is statistical. So hypothesis testing is about measuring statistical differences. It is assumed that 100 kwacha will give you 10 liters. So when you go to about 50 filling stations and they're giving you 9.8 liters, that's 0.2 liters, which is different. If you conduct an hypothesis testing and you find your answers in the rejection region, you can sue those people through the CCPCS. I don't know what you call competition, something that they're stealing from there. client. So hypothesis testing is very good because it helps us magnify or insignify the differences that exist between parameters that are there. Are you getting the logic? So our song can now change. So we've been dealing with what we call a two-tailed test, where equal to or not equal to were the signs we are going to consider. So 99% TK, the next one is what? 98. The next one is what? 95. Then we have what? 90. So what is the Z for 99? 2.58. This under a two-tailed test. What is the Z for 98? 2.33. What is Z for 95? 1.96. What is Z for 90? 1.645. But if we are using signs greater or less than, we call this a single-tailed test. So single-tailed test is just alpha over 1. So our Z for 99% is 2.33. This one goes up and this one also comes somewhere there. For 98, it is 2.05. For 95, it is 1.645. And for 90, it is 1.28. So these are the new values that we get for a single-tailed test. So if you hear a biased angle of the question, for instance, it is assumed that workers are underpaid already. Under means what? Less than. Workers at KCM are underpaid. It has given you already a biased statement. Underpaid, okay? They get 10,000. Okay. And when 100 were sampled, or it's assumed they get what? 10,000. And when 100 were sampled, they found to get what? 8,000. We found they get 8,000 with what? 500 requires a standard deviation. Test the claim. Test this claim at 5%. So when you're conducting a test, underpaid, the synonym or sign is what? Less than. Overpaid is greater than. So when you go here, it's you put that what? That bias statement mainly in the alternative hypothesis. So say mu is what? Less than 10,000. Then here, you can just use equal to equal sign. 10,000. Step 1. Step 2, set the level of significance here. Level of significance is 5%. So the under will give you a biased tail. It's a single tail. So we're going to look at it from the left side. If it was greater than, we'd have used it from the greater side. So 5% ideally is supposed to give you 1.96. That is for a two-tailed. But this is not going to hold because we're using a single-tailed test. When we need to rememorize this. So at 5%, which is 95%, the Z we're going to look at is negative what? 1.645. The one which was for 90% in the other. So here we're going to have 1.645. So this is our critical value. We're going to use a negative because of the weight less than. Then we're going to go to step 4, where Z calculated is what? Mean minus mu, standard deviation over square root of what? N. So here we have 8,000 minus what? 10,000 over standard deviation is what? 500. Square root of how many? 100 what? Employees. So if we get our value of Z as negative what? -2. -2 is in the rejection region. So we don't accept this, we reject. So rejecting a hypothesis means we are embracing the alternative hypothesis, which means these guys actually get what? Less than 10,000. So can you accuse them of paying inferior wages? Yes, can accuse them. Suppose we got our Z as what? -1.5. -1.5 could be inside here. So it is accept region. Accept region simply says, actually, 8,000 they get is as good as 10,000. So they're not being underpaid, they're within range. So accepting hypothesis simply means that what is being claimed and what is on the ground, there is no statistical difference. All right? There's no statistical difference. Okay. So are we following together?
Sorry, Collins, I missed one part. How do we know when it's a single toe?
The weights that are there, greater, more than, effective. So you will always find words that are suggestive, especially regarding single and double. So you see that mainly as we look at several examples that I will show you. So you find comparative terms that will lead you. Okay. Any other questions? Any other questions? So I have a very nice book. Which is called Introstat. Let me try to. Okay, what's your? I'm looking for it. Any questions? This is a book called Introstat. The book that was used some time back. So let me look at the question to do the single-tailed test and the double-tailed test. So let's look at this question here. We're told that a farmer who has used a specific fertilizer for many years knows that the average yield is 2.5 tons per hectare with standard deviation 0.553. The fertilizer is discontinued, he has to use a new brand. He suspects that the new fertilizer will alter the yield, but doesn't have no idea whether it will be an increase or a decrease. At the end of the season, he finds that the average in the 5 plots has been 2.65. At 5%, test whether the sample is statistically different. So from this statement here, number one, we need to analyze 5 key things. Start with the farmer who knows for many years the yield historically is what? 2.5. So this is called our mu, not our x bar, because it's the historical mean. Then the standard deviation there is what? 0.53. The fertilizer is discontinued and wants to use a new brand. It is suspects that it will alter the yield, but has no idea whether it will be an increase or a decrease. So here we're going to use a two-tailed test, equal to or not equal to. But if he has an idea it will be an increase, we would have used greater. If he has an idea that we have a decrease, we have used less than one of the two, but he has no idea. At the end of the season, he finds in 35 plots. So this is our N, 35 plots, that he has been, the average is 2.65. So this is our X bar. Why? Because it was calculated from 35 plots. Test at what? 5%. So since it's a two-tailed, 5% here, we're going to use what? 1.96. But if we had a hint that this would be a decrease or increase, it would be a single tailed. So to be a single tailed test, would have used what? 1.65. So let's go to the procedure. Step 1, set the hypothesis. Mu is equal to 2.5, mu is not equal to 2.5. Step 2, state the level of significance, which is 5%. Step 3, draw the decision critical values, 1.96. So this is called the rejection region and the accept region. Step 4, calculate what we call the test statistic. So x bar minus mu, standard deviation over root of n, 2.65 minus 2.5. So we get 1.67. Where is it? It's somewhere here inside. So what does it mean? It means it's within the rejection, within the accept region. So what is our conclusion? We say that it is not statistically different. We accept, because whenever we accept, there is no statistical difference. All right. So here the fertilizer is what? Useless, because it does not give a statistical difference whether we use the old one. It is almost like we're using our old fertilizer. Now let's look at question 15a. To say identify the single-tailed test. So the weekly semi wage for workers in an industry is assumed to be normally distributed with a mean of what? 286, standard deviation, which is 29. The company in this industry has a sample of what? 40. And the average is 271. Can they be accused of paying inferior wages? So this word inferior is less than, so we know it's a single-tailed. So in this alternative, we're going to put less than. But which one is our mu and our x bar? 286 is our mu, because there's no sample size. Our standard deviation is 29. But 40 is our n. So then average attached to the 40 is 271. So this is our x bar. Are we following? So what goes in the hypothesis is the mu. So mu is equal to 286, mu is less than 286. So inferior gives us the symbol less than. Step 1. Step 2 here, we have not been given what? Our significance level. Whenever we're not given, the standard is 5%. But in this example, they used all the percentages just to explain had it been. So we know that 5% is not 1.96, but in this case, we're going to get 1.645 or 1.65, either of them. All right. 1% is supposed to be 2.58, but since it's a single-tailed test, we're going to go 2.33. All right. So if they're going to use 0.1%, all these are the figures. So you need to now understand the song under the single-tailed test. So let's start with the song under our double-tailed test. If you remember, what is our song? 99% is what? The double-tailed test. 2.58. 98,
2.33.
95, 1 point,
1.96.
and 90, 1.65.
1.65.
If we're dealing with a single tailed, what is our Z for 99?
2.33.
98,
1.96.
1 point, about 90, 95, 645,
1.65.
and 90,
1.28.
great. You need to know this song for own goodness. All right, so this is where these figures are coming from. So if we're going to use 5% inferior, we're just going to use the left part of it. So negative 2.64. So don't get confused. 1.64 is acceptable, 1.645 is acceptable. 1.65 is also acceptable for a 90%. All right. Or a 5% under a single tail test. Yeah, or depending on the focus that you're going to use. Then you calculate the Z. So this is Z is negative 3.16. So under a 5%, we will reject our null hypothesis and we conclude that they are underpaying the workers. If we're going to use 0.05 level of significance, at this point, of course, this is the most extreme. You can now say, okay, here now they're within range. So you need to make your decision based on the significance levels. So you'll be given significance levels, but if you're not given a significance level, the standard is 5%. Are we together? Standard is 5%. All right. So,
Please, can we talk inside?
So, madam with the iPhone, kindly mute your.
so the specifications for extra X have a mean of 125 and standard deviation of 6. Sample of 24, repeatedly extra X had no average, had an average mass of what? 123.2. Are the eggs smaller than the specification? So the word smaller is synonymous to less than. So the average standard is 125. So 125 equals here smaller than 25. And we sampled 24 eggs and they were found to be having a mass of 123. So 123 is our what? Is our X bar because they're attached to a sample size. So 123 minus 125, 6 root 24. Our Z is negative 1.47. So since less than, and what percentage are we using? If we're not given a percentage, we assume it's 5%. So at 5%, what is our statistical value? 5% is what? Negative 1.64. So this 1.47 is somewhere inside here. So we can conclude that are they statistically smaller? No, they are the same. So meaning this and that have no statistical difference. But if we're using 10%, 10% is the same as what? 90%, which is 1.28. So we have 1.28 there. 1.28. Then the figure we found is negative 1.47, which is in the rejection region. So at 10%, we can say yes, they are statistically different. So you need to know which level of significance you're using. All right. So we're going to end our class here on hypothesis testing. This is one of the most critical topics. Hypothesis testing goes with estimation and sampling. They move hand in hand. You cannot do one without the other. Thank you so much for your time and have a good night.